Now let's imagine with me, if you will, that I have an equation, y equals 2x plus 4. And for your benefit, I drew that equation, or I drew the solution of the equation in graphical form on this plane. And I also found its y-intercepts and its x-intercepts. Its x-intercept is negative 2 and 0. Its y-intercept is 0 and 4. What I don't really know right off the top is what its slope is. But we found, and we know how to deal with slope. We've worked with it before. We know that slope are its change in y's over its change in x values. I've designated this one as my second values. These are my first values. So x or y2 minus y1 all over x2 minus x1. Slope becomes negative 4 over a negative 2, which equals a 2. That's a bad 2. There's a 2 in there somewhere. So this line has a slope of 2, or its steepness is 2. And also, too, this might be a little side note, that its steepness or its slope is 2. That really means 2 over 1. It's rise over run. It goes up 2 for every 1 unit. Up 2 for every unit. Up 2 for every unit. 1 unit, and so forth. Well, what I can start to notice, and some of you have already started to notice this, is that I can sometimes identify its slope by just looking at the equation. See this 2? There's a 2 right there. That's not a coincidence. This 4, there's a 4 right there. Also not a coincidence. And I want you to prove this to yourself with the practice that we'll do in some of the homework problems. But what this is this is in the slope-intercept form of a line. Anytime I can write an equation such as y equals some x plus some constant, that immediately gives me some information. And we call that slope-intercept form. We write it as y equals mx plus b, where m equals its slope and b equals its y-intercept. So I can look at any line and I can start to graph that line if it's in this form right away. Its slope is 2 and it crosses the y-axis at 4. And I think that's enough information for me to graph the entire line.